Hi, Joseph.
Hi.
How are you doing today?
Good.
Things still going well in your geometry class?
Um, Not really.
What's that?
No, not really.
No? Okay.
No.
Well, you tell me where you want to start here. I pulled up the first document.
Mr. Cohen,
Yes.
this is Joseph's mom, Erin. How are you?
Hi, Aaron. Good.
Joseph got a 71 on his last math test on Friday,
Okay.
which is the lowest grade he's gotten on any of his math tests.
Okay.
I'm bewildered at where his grade is and why, and he has no answers. His teacher tells me he's real bright. He seems to understand geometry, so I'm having some really hard time with this.
Uh-huh. Well, I don't blame you. Last time I talked to Joseph, he had gotten 100 on his previous test. So,
He got a quiz. He had a quiz. He had a small quiz worth like 3 points that he got 100 on.
okay.
Look at Friday and got a 71.
Yeah, well, I'm not sure what's going on. Joseph seems to understand the stuff pretty good when we cover it. Yeah,
I would like him to get all of his math tests. I mean, I don't even know if starting over. I mean, this can't go on. This is a straight A student. He got hundreds in all of his grades last year in 8th grade. I get that it's high school. I get all that stuff. But I can't have a C in geometry.
no, you certainly don't want that. Well, I will work with him, taking that information into account.
Okay. Should I be concerned? Do you feel fine? I mean, I guess I literally almost fell out of my chair. I would have
Well,
taken him.
this has kind of hit me like that also, because my understanding is that he was doing really well in geometry up until today. So I will look for areas that he might be weak in.
We can get his test and we can look it over. I mean, I can't go take a test for him, nor can you. And
That's right.
I would love for him to continue tutoring, but if it's not going to help, I just don't know what to do. And I don't know that he's taking me seriously.
I don't feel like that's the problem. I do get that sense from some students that they just aren't really trying hard enough, but
Okay.
I don't get that sense from Joseph.
Okay.
I feel like he's pretty motivated. I don't know. It might have been a particularly tough subject material that caused him to get that score. I just don't know without examining that test and seeing what he got wrong.
Well, as soon as we get those tests, we'll get them over to you.
Okay.
Okay. Well, Joseph, I don't know what else to do other than just to go through all of these and see if you understand them.
Yeah, it's
So
weird.
let's start with you want to start with 1 or do you want to direct me?
I think I'll just go with 1.
Okay. If a plane contains one of 2 skew lines, it contains the other. True or false?
False.
Correct. Skew lines lie in different planes. So, if a line and a plane never meet, they are parallel.
True.
Yeah, I guess that would be. In other words, the line would have to be in a plane that was parallel to the other plane. If 2 parallel lines lie in different planes, the planes are parallel.
False.
If a line is perpendicular to two planes, the planes are parallel.
True.
Okay. If a plane and a line not in the plane are each perpendicular to the same line, then they are parallel to each other.
True.
All right. Let's look at number 2. All right. First of all, on number 2, what you want to recognize is that that is the equation of a circle whose origin or whose center is at the origin.
Mm-hmm.
That's just the standard format of a circle. And actually, the standard format is x squared plus y squared equals r squared, the radius of the circle squared. Okay. And that's why this equation says x squared plus y squared equals 25, is because the radius is 5.
Mm-hmm.
Now, it says by substituting 3 for x and 4 for y.
So 9 and 16.
Equals what?
25.
And it does.
Mm-hmm.
I saw an interesting statement on Quora. I don't know if you're familiar with that. Quora talks a lot about math and science. And it said a circle is one-dimensional. That might seem like a very strange statement. But the truth of the fact is that this circle, given by that equation, is that line.
Mm-hmm.
That is a one-dimensional line. In other words, most people, when they think about a circle, they think about the area inside, which obviously, if the circle has an area, it's two-dimensional.
Mm-hmm.
But the actual equation of a circle is strictly the circumference. Now, if you want to say x squared plus y squared is less than 25, then you have a circle. But all right,
Mm-hmm.
let's have another look at next problem.
Mm-hmm.
So they're telling us that the plane R is parallel to the plane S, which is parallel to the plane T. And then you have a line segment, AE, that's parallel to BF.
Mm-hmm.
Prove that R is parallel to T. And that ABFE is a plane figure, and AB is parallel to EF, and AB is parallel to E, or AB is congruent to EF.
Mm-hmm.
All right, let's figure out how we're going to prove all this stuff. Well, if we take here, hold on. If we take those two statements, what can we derive from that?
If two planes are parallel to the same plane, then the other one is parallel.
So that's proved right there. R is parallel to T.
Mm-hmm.
And the second thing is ABFE is a plane figure. ABFE.
What is a plane figure?
Well, that's a good question. It's a solid plane. It's all on one plane. In other words, you don't have two different planes, if you can picture that.
Oh.
Take two playing cards. Okay, that's one playing card. That's another playing card. If they're on the same plane, then they're a plane figure.
Mm.
If there was an angle between them, in other words, if you tilted one playing card so that it was not on the same plane as the other playing card, then it would not be a plane figure.
So they have to be on the same plane.
Have to be on the same plane. And the only information they're really giving us, other than that we know that all three planes are the same, and that we know that AE
Is parallel
to BF, well, that means they're both lines, right?
Mm-hmm.
So there cannot be an angle at CD.
Mm-hmm.
Because otherwise you would not be able to have AE parallel to BF.
Yes.
Here's what I'm kind of trying to say is, here's your two playing cards, and then if this one here was at a slight angle, so that there was an angle there, then those two playing cards would not be on the same plane. But the fact that they've told us that AE is parallel to BF, well, that tells us that AE is a line and BF is a line. Well, that's not a line. So the only way that can be a line is if those two cards are directly on top of one another. In other words, if they're in the same plane. AB is parallel to EF.
Since they're on the same plane, doesn't that mean that they're parallel?
Well, yeah, basically. In other words, this right here, where we've proved that R is parallel to T, that proves that AB is parallel to EF. There's no way that it could not be. Especially if ABFE is a plane figure. If it's a solid plane, which if I have two playing cards directly on top of one another, then that has to be parallel to that. And AB is parallel or congruent to EF. Well, if we know that AE from this statement is parallel to BF, it's like having two parallel lines or three parallel lines, and that would have to be congruent to that. And that's essentially what we have here.
Yes.
In other words, there's no twisting. Since we've proven that ABFE is a plane figure, we know that the plane on AB is parallel to the plane on EF. The only way that AB would not be parallel to EF, or congruent, I'm sorry, is if there was some twist in here. You know what I mean by that?
Yeah.
Okay. Well, as long as there's no twist, and we've proven that because it's a plane figure, in other words, it's a two-dimensional plane, it's not three-dimensional, then AB has to be
Equal.
Congruent to EF. Now, if we've proved all these lines are parallel, well, then we have a parallelogram, right?
Mhm.
Parallelogram is two opposite and equal sides that are parallel and equal. So this is the last part of that definition of a parallelogram. This geometry that you're doing here, this is not standard geometry. This may surprise you. But when you take your ACT and your SAT tests, they will not ask you any questions about planes and skew lines and stuff like that. This is all a little bit beyond the Common Core in geometry. Now, maybe that's what happened on your last test. I don't know. I don't know if your last test was material that we went over or covered or not. But yeah, this is unfortunately an awful lot of geometry is like that, where they give you stuff that you're never going to have to know again, but you got to know it to get through your geometry class. So I don't know what else to tell you, but yeah, the distinction between planes and skew lines and all of that is really kind of extracurricular geometry. All right, let's look at number 4. Given that GJ and KH bisect each other at P, makes that equal to that. That equal to that. Doesn't say they necessarily are all equal to one another. In other words, if I have a parallelogram like that, my two diagonals definitely bisect each other, but they are not the same list. This is not the same. That's the same as that. That's a different length. And that same thing's going to apply to this. At the moment, the only thing we can assume that this is a parallelogram. Not sure that we can assume yet that it's a rectangle.
Yeah.
In other words, that does not make it a rectangle, because we've seen from parallelograms that the diagonals bisect each other. So far, all we know is that we're dealing with parallelograms. Is GHJK a plane figure?
Yeah, because it's just lines. There's no room for angles.
Well, in other words, could there be any bends? If we consider this thing a playing card, is it possible that it could be bent, which would not make it a plane figure?
No.
Not sure of that. Let's see. GH and KH bisect each other at P. I guess that assumes everything's a straight line. Even though I could imagine this thing being a playing card and bending it a little bit. And then all of that would still be correct, except those wouldn't be line segments. They'd be curved. So I guess that has to be a plane. So, okay, so that's a true. Are GH and KJ parallel?
Yeah, because
whether it's a rectangle or a parallelogram, the only way the diagonals bisect each other is if it's one or the other. We still don't know yet whether it's a rectangle or a parallelogram. In other words, if I look at my parallelogram up there and assume that is the picture, well, the problem with three-dimensional geometry is it's so hard to draw. If we go down and if I try not to draw it and I try to base it on their drawing, I made that slanted, I would still have two planes on each side of one another. See, the question is are GH and KJ congruent? Well, okay, yes. Even if it's a parallelogram, they're congruent. Because parallelograms have two opposite sides that are congruent.
Mm-hmm.
At this point, I believe that this figure could be a parallelogram. It doesn't have to be a rectangle.
Mm-hmm.
Because you could still put a plane on the end of that one and a plane on the end of that one, and those planes would be parallel. Although it hasn't even asked us that yet. It's asking that now. Are planes E and planes F parallel? And I believe the fact that as long as that thing in the middle is a rectangle or a parallelogram, then those two attached planes have to be parallel.
Mm-hmm.
In other words, if you stick a plane on the end of that piece right there I can draw it. And you stick a plane on the end of this piece right here, those planes would be parallel.
Mm-hmm.
As long as the sides are parallel.
Yes.
What is the most descriptive name for GHJK?
Wouldn't it be parallelogram because we don't know?
Parallelogram. We still don't know. The most restrictive, if it were a rectangle, we'd say rectangle. Because rectangle is more restrictive than parallelogram. But everything we've looked at this point, it seems to me that that could be a parallelogram or a rectangle.
Mm-hmm.
Which means the most descriptive would be parallelogram.
Yes.
In the figure below, find the slope of the chord EF, then find the slope of the chord FG. What type of triangle is that triangle and why? Blow this up a little bit bigger so I can see it a little easier. Hold on. I'm thinking. Well, the slope of EF is a relatively easy problem. That's not a geometry problem, that's an algebra problem. What's slope equal to?
Y2 minus Y1 over X2 minus X1.
So in this case,
the slopes would be 1/2 and
between E and F, we want the slope of EF, this one right here.
mm-hmm.
So use that formula. What's Y2 minus Y1?
Y2 minus Y1 is 4.
Okay. And what is X2 minus X1?
That is 8.
All right, so that slope is 1/2.
Mm-hmm.
And the same formula apply to FG.
FG, 4 over 3 minus -8. Not negative. -2. -2. So it'd be -2/1.
What do those two slopes tell you about those two lines?
It forms a right angle.
Correct. In other words, that two lines that are perpendicular to one another, the one slope is the negative reciprocal of the other slope. So what kind of triangle is it?
A right triangle.
Right. Yeah, that's a little more traditional geometry. I personally think that it's kind of a mistake to introduce this three-dimensional geometry at this point, but the heck, we got to deal with what they give us, huh? All right. So we have M, the plane M is parallel to the plane N. And we have AB parallel to CD. Prove that AB is congruent to CD.
Well, if we prove that it's a plane, then we know that CA is equal to DB, or AB is congruent to CD.
Okay. Yep. Because this thing is either a rectangle or a parallelogram. Again, I don't know that we can prove that it's a rectangle, but it's definitely at least a parallelogram, and parallelograms, opposite sides are congruent. And that's what we have. That side there has to be congruent to that side there. All right. So the plane E is parallel to the plane F. RT intersecting with VS equals P. RS is congruent to VT, so that is congruent to that. This statement right there, that just means they cross, right? Doesn't say anything about anything else.
Yes.
Okay. Prove that RV, this one, is congruent to ST. Well, we need to prove that's a parallelogram again. Well, if that's congruent to that, and that plane is congruent to that plane, that means RS is parallel to VT. So again, we have either a rectangle or a parallelogram, and with either case, RV would be congruent to ST.
Yeah.
So pretty much all these problems, except 5, comes down to proving that something is either a parallelogram or a rectangle.
Correct. Those are the only problems that I have to do.
Oh, okay.
Yeah.
Well, if you're looking to improve things, you need to bring me more problems.
Yeah.
I've noticed a couple of times you only bring me a half hour worth of problems, and we're scheduled for an hour session. Now, I have no problem with a half hour session, but
But if I need more help,
Yeah, for tomorrow, you might want to make sure that we have an hour's worth of problems to work on.
yeah.
Whatever that means. These kind of problems you're getting here are actually rather difficult to get out of a geometry book because they're beyond the common core of geometry. Your teacher is getting these problems from probably somewhere other than his geometry book. These are a little different than I'm used to coming across. Might be one reason you had problems in your last test.
That was a bad test.
Well, there are certain things in geometry that you really need to know, and then there's the stuff that goes beyond what you need to know. It's like proofs. No SAT or ACT test will ever ask you to prove anything like what you're used to being asked to prove. That's not part of it. That's beyond the scope of high school math. And I can honestly say, as a math graduate from School of Mines, that you don't even get that in higher up math. So I wouldn't be too discouraged about poor performance on this material or a previous material that was similar. You can get through it. It's a little bit like getting through proofs. Everybody hates proofs, but once you get through it, you tend not to have to revisit it ever again. And I suspect you're very close to that point.
Yeah, we're almost done with proofs.
Yeah. Yeah, you will find the second half of geometry actually to be quite a bit easier than the first half. For some reason, all the tough stuff is put in the first semester. I'm not sure why.
Yeah.
Second semester deals with more traditional geometry, triangles, squares, rectangles, parallelograms, and some three-dimensional stuff, but not planes that are parallel to one another or things like that. All right. Well, Joseph, I will let you go, and I will talk to you tomorrow. Try to have a few more problems tomorrow if you could.
Yeah, I will. I think I'll do all the review problems for chapter 6.
Okay.
Yeah, that should definitely take us an hour.
Yeah, well, yeah, it's okay if you have more, but just when you have less, it's hard for me to come up with similar types of problems as the ones we've just done.
Yeah.
If I had, another page of those kind of problems, I could do them with you, but I don't. So,
yeah,
need you to bring this stuff.
Yeah.
All right, Joseph, I'll talk to you tomorrow.
Yep. Thank you.